Welcome back, students. So today our topic is half adder, and this is in continuation to our lecture series regarding the topic combinational circuits. Now how will we define half adder? It is a combinational logic circuit with two inputs and two outputs. So this is the first point to remember, that there are two inputs and those two inputs have been referred as x and y, and we have read in previous classes that this is nothing but a truth table. So two inputs are there and they have been assigned names x and y, and two outputs, and those two outputs are sum and carry, because it's like once we are adding two numbers in decimal also. So these two are the number, and once we add 3 plus 7, so 10, we write 0 with carry 1. So this 0 is called as sum and this 1 is called as carry. So again then what we do, 1 plus 1 plus 1 is 3, right? So this is how we get the output. Similarly here in the binary also, once we add, there are two outputs, one is the sum and the other one is the carry. Now we have also said last time that this can be any kind of a black box, and we want to know what is the circuitry behind this black box that we have called as half adder. And I hope that you must be remembering those 4 steps that we have covered in our design procedure. So the first step was we have to determine the number of inputs and outputs, right? That has to be determined, and we have to assign the names. And we know that it is a combinational circuit with two inputs and two outputs. And the logic of this is because once you have to add, then you need at least 2 digits, right? Like 2 numbers you need. Digits can be single also, but you need 2 numbers, let us suppose a and b. So that is why 2 inputs are at least required, right? Which can be any 2 numbers. Then 2 outputs, and what's the logic of this? Because 2 outputs will be sum and carry. That is what happens once we add. So that step is determined. Second one is you create a truth table out of it. So again recall, what is a truth table? It's a table that will give all the possible combinations of the inputs and their corresponding outputs. So that is what is a truth table, and now we will see shortly how this table is being created. Then the second point in the definition is that the half adder circuit and 2 single bits without any carry is called as a half adder, because you have to understand this concept that adder, it can be full adder also, or it can be a half adder also. So how will you define half adder and how will you define full adder? So in this video, like, we are focusing on half adder. So it is an adder where we are adding the numbers without any input carry, and this will be more clear once we will be studying full adder in the next video. So that is what is given in the second point. Once we talk about half adder, then we are doing addition without any input carry. Now let us understand how this table is created, because this is our step number 2. Once we will find out how this table has been created, so the other steps are then easy. From this truth table we will get equations, okay, using K-map or simple Boolean laws, depending upon which method is easier for us. And the last step is the logical diagram, right? We have read all these steps already in our previous lectures. Now let us come to step number 2. How did we create the table? Alright, let us see. We are taking example of a single bit here, actually, single bit. Now single bit, it can be 0 or 1, right? Now once we add, there are 4 possibilities, or you can study in this way also. If suppose there are 2 inputs, then what are the maximum number of combinations? You should remember, for n number of inputs, maximum combinations that are possible at the output will be equal to 2 to the power n. So n is 2 here because we are having 2 inputs, right? So 2 inputs correspond to 4 output combinations, okay, or you can say 4 combinations in the truth table. What are those 4 combinations? 0 0 0 1 1 0 and 1 1. It's like 0 1 2 and 3 in the decimal. Now what actually we are trying to do, we are trying to perform addition, because ultimately it is an adder circuit, right? So let us have 4 possibilities. So what are those 4 possibilities? We are adding 0 plus 0 in case number 1. Now what is 0 plus 0? It's very simple. Even in the decimal you can correlate. 0 plus 0 is 0, and obviously there is no carry. So sum is 0 and carry is also 0, right? So that is why it is 0 and 0. I hope it is clear. Coming to the second case, it is 0 plus 1 we have to add. So what is 0 plus 1? So 0 plus 1 is 1 only, right? So sum is 1, and do we have any carry? No, carry is 0. So sum is 1, carry is 0. So sum is 1, carry is 0. So this is also clear. Now coming to the third one, 1 plus 0. So it is again the same thing actually. 1 plus 0 is 1 and there is no carry. So sum is 1, carry is 0. So it is same thing, right? So you can see both are same. Now the interesting one and the important one is the last condition, which is 1 1. Let us do 1 plus 1. Now see, 1 plus 1 in decimal is 2, right? We know it is 2, but 1 plus 1 is 2 in decimal. But right now we are dealing in the binary, which means number can be either 0 or 1. So what is 2 in binary? 2 is nothing but 1 0, right? 2 is nothing but 1 0. So when there are two digits, we cannot write both the digits. We have to write only the first digit, which is 0, and the other one will be carry. So this one is actually carry. It's like the same thing. If suppose you have 19 plus 17 being added, so what will we write? 9 plus 7 is equal to 16. So we will not write here 16 then 1 plus 1 is 2. That is wrong, right? So what we do is we will say 9 plus 7 is 16. So 6 with carry 1, right? So then 1 plus 1 plus 1 is 3. So that is the right answer. So this is the concept. This is my sum and this one is my carry. So in the same concept, 2 is 1 0. So this is my sum and the second digit is always the carry. So we can say sum is right now 0 and carry is 1. So you can see here sum is 0 and carry is 1. So these are the 4 conditions with which this table has been completed. I hope this is clear. Now if we will see to our design steps, we are done with step number 1, 2 and 3 because step number 2 is done. Now we have to do the step number 3, which is getting equation. Now if you remember the example we covered last time, code conversion, we needed k-maps over there. In this particular case, because there are only 2 inputs and we are having a smaller table, so k-map is not necessary. Although you can use it, there is no problem, but we can do it without k-map also. Let us see how can we do things without k-map here. It's very simple. Let us talk about C column. Okay, C is carry and S is sum. Also you may note down, last time I told you some important things, that number of equations is equal to number of output columns. Number of output columns. So we have 2 output columns because it is referred here, right? 2 inputs and 2 outputs. 2 outputs means 2 output columns. So there must be 2 equations. One equation for carry, one equation for sum. Now without k-map, how you do it? In this k-map, in this truth table, in the carry column, first of all, we will see the min term being 1 or the output being 1. The output is 1 in this particular case. And corresponding to this, we will see what are my inputs. So it is x1, y1. So it will be x dot y. Simple. Alright. Similarly, same method we will apply for the sum also. So what is the first step? Select this column, right? Then see the locations where the output is 1. It is here and here. Now corresponding to these two, we will see what is the input. So what is the input here? X is 0, y is 1. So we will write x bar y. Why x bar? Because 0 will correspond to complemented input, x bar. Y is 1, so we have written y. Then we are having one more 1, and let us see what is the x and y value. This is x and this is y bar. X and y bar. So if you will see x dot y, it is nothing but AND gate, right? AND gate is like A dot B kind of equation, and x bar y plus x y bar is nothing but XOR gate. So the story is simple now. Once we will convert these equations, this which was our step number 3 into step number 4, we can simply replace it with this diagram in a simpler way, because you see this is x and y, so this is x here, y here, so this is an AND gate, so this is x dot y, and this is x and this is y, and this is XOR gate symbol, so this is x XOR y, right? So this is the last step. Now coming to the diagram which is available in the middle. what is this diagram? Now this diagram that is available in the middle is also the same thing, except one change is there. Instead of using directly XOR gate, which is here, we have used the basic gates. What are the basic gates to implement? X bar y. So you can see here x y bar, so this is x into y bar. Similarly x bar and y, this is x bar y. Now this is OR gate, you have to simply add these two inputs, so it will be x y bar plus x bar y, which is nothing but the equation that we got here. So this is a simplified way of doing it. This is directly using XOR gate. So this is the only difference. But if you look at carry, both the diagrams are same. So this completes our topic of half adder. There are few questions for you. Let us solve it. The question is, if A and B are the inputs of a half adder, then what is sum given as? So if you will remember it from our previous section, we got two equations. Sum was there equal to A XOR B, and that is given in option number C. So C is the right option. Now the next question is for you. Can you tell me what is the equation of carry? You can answer in the comment section. What is the equation we got? There's one more question for you. The total number of inputs in a half adder is. So how many number of inputs? So we were having only 2 inputs, right? So the answer is 2. The question for you is, how many number of outputs? What are the total number of outputs in a half adder? So 2 questions I have solved. The answer here was A XOR B for sum. Now carry you will tell me in the comment section. Similarly, the number of inputs in a half adder was 2. Now how many outputs it has, you will again tell me in the comment section. Further, if you are having any questions also or any doubts, do raise them in the comment section. I will see you in the next class, in the next video. Till then, take care and have a nice day.